Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. Today, as with many of my screencasts, I'll be discussing the reciprocal system, in particular the reciprocal system Microcosmos database, which you can see on the left panel here. I've already covered all the layouts on the reciprocal system Macrocosmos database, so please see my other screencasts for all those. On the Microcosmos database, we've already covered solid matter properties and liquid vapor gas matter properties, so we're going to come into this area here, cosmic elements, subatomic particles. We're going to cover cosmic elements today. So what are cosmic elements? Well, first of all, there is no antimatter and there's no dark matter in the reciprocal system. There are two types of matter, material and cosmic. Cosmic matter is the inverse of our ordinary material matter. There are 118 cosmic elements, just as there are 118 material elements, with the 118th element being unstable regardless of the region. If you tried to make an element with the atomic number greater than 118, either in the material sector or the cosmic sector, it would decay immediately regardless of the environment. So, atoms, both material and cosmic, are rotating photons. The distinction is that the rotation of material elements is in time, which means it's less than the speed of light, whereas the rotation of the photons in the cosmic sector is in space. So the first element, the first actual element in the cosmic sector is cosmic deuterium. This is C-D. We prefix all cosmic elements with a C hyphen in front of it. Description, cosmic deuterium. And here's the regular rotational displacements. It's 2 in parentheses, 1 in parentheses, and 1 without parentheses. So it's the primary or principal magnetic rotation is 2 units in space, and then the secondary magnetic rotation is in space also, it's 1. And then there's a unit of electric rotation in time, it's one-dimensional. Form number 1, if you wanted to play around with the record, but you didn't want to change anything in the record, you could just duplicate the record by hitting Control-D, up the form number, and then play with the other numbers. Now this one is pretty simple. There's just the Z factor here. There's 2 over Z, so we have the AMU here, which is precisely 2. This is AMU is based on oxygen, whereas U is based on carbon, incidentally. So there's a slight difference between the two values here, 1.999, etc. for U. So just keep that in mind. The reciprocal system is more consistent with the old oxygen basis than with the newer carbon basis, but we give both here. G sub C means the number of gravitational units from the cosmic sector, and the mid-range calculation. So it's less than 1, obviously, lowest value and highest value. So it's really 0 for this. Number of material gravitational charges as observed would be 2 in this case. So then we get G sub C here in cosmic terms. Because it's 0, 0 there, 0 for U. And then here, this is the mass of the cosmic isotope as would be measured in the material sector. So there's U here, and then commonly with mesons. And by the way, the conventional theorists refer to all these cosmic elements as mesons because they're intermediate in mass between, let's say, hydrogen and the electron. But the reason for that is that cosmic atoms have the inverse mass to material atoms, so keep that in mind, please. And then down here we have the most commonly observed C-D psi. That's the identification of the meson psi particle. G sub c is 0. The number of material gravitational units is 2. That's a rotational vibration, by the way, caused by neutrinos. There's the MeV over c squared, which is the common unit, in particle experiments. The observed value is pretty close, you can see. And then the decay products. Now, cosmic deuterium can change right over to material deuterium, so that's a possibility, or it can change into cosmic helium. So, I say here in the notes, cosmic deuterium converts to D because each unit cosmic rotational system is equal to a unit material rotational system. However, there may be situations where it decays to cosmic helium-3. Note that CH1 is an intermediate particle because the rotational systems are different. So C-D is actually the first real cosmic element. Okay? If you look down here, you can see 118 elements in this particular database file. So I'll go to the next one. Here's cosmic helium. Pretty much the same stuff you saw before. I will note here that G sub C can be a minus number. It doesn't have to be positive. Again, material gravitational charges. This is another psi particle, but the G sub C and the G sub M are different. So we get a different value of 3105 MeV per c squared. And then this can decay to cosmic boron or cosmic carbon or cosmic nitrogen. And here's cosmic lithium. Again, -1 to 1. I'm not going to go through all the elements. I'm just going to just briefly go through. Let's go to cosmic carbon. Here we have 0 to 1 for G sub C and 1 material gravitational charge. And so we get these results here. And this is identified as a delta particle. Okay? Let's see. Okay, that one, cosmic nitrogen, oxygen. Some of these don't even have identifications yet. Let's see. Silicon. Yeah, pion, so yeah, that's what that is. So this is a pion. That's pretty important. Cosmic silicon is the pion. And these are the different masses involved. Cosmic phosphorus. Let's see what else is interesting here. A lot of these don't even have. Okay, so here's K, cosmic krypton. Now I have the identification as a kaon, but you got to read the notes here. The usual kaon is 1/2 of a cosmic krypton. That is just one rotating system rather than two. It therefore has a mass of 491.457 MeV per c squared. Assuming 1 material gravitational charge. Cosmic krypton decays to 2 massless neutrons, which are difficult to detect. These massless neutrons then eventually combine with material neutrinos to create protons. Okay, so that's how that operates. I think we've covered probably enough here. I'll just go through, see if there's any other major identifications. You can see as we go to the higher atomic number, then we have more possible values for the cosmic isotopes. Look at this cosmic cadmium. Wow, a lot of different isotopes here. And these fragment when they come in. If you get a cosmic lanthanum coming in, It's just going to fragment. Alright, well, that covers the cosmic elements. Again, cosmic elements are the inverse of material elements. There's no antimatter. There's cosmic matter. But cosmic matter is localized in coordinate time. So yes, there are cosmic stars, cosmic galaxies, etc. But they're not localized in space, they're localized in time, so we could only encounter them ordinarily one atom at a time, or one molecule at a time. The two sectors, the material and cosmic sector, actually pass right through each other. We're moving outward with the space progression, whereas the cosmic sector is moving outward with the time progression. Velocity in our sector, as I've said many times, is s over t, whereas it's t over s in the cosmic or inverse sector. So now you understand why we call the whole system the reciprocal system. Space and time are supersymmetrical in space-time, or motion in the most general sense. Alright, so that wraps it up for today. I'm just going to close out here. Study the reciprocal system and prove it for yourself. The simplest possible treatment of the theory is my work, The Unmysterious Universe. Has all the diagrams you need, all the concepts, and it has a critique of conventional theory in there as well. Still in print after many decades, and it's gotten very good reviews on Amazon. Now, if you do want all the mathematics, though, please get my magnum opus, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. 711 pages in the PDF file, 1711 slides in the PowerPoint file, thousands and thousands of equations. And I should point out it has all the dimensions of all the physical quantities, all reduced down to space-time terms. There's nothing like this in the world. It has thousands of equations, as I've said, numerous diagrams, tables, figures. It'll keep you busy for months. Then, when you're finished with that, you're ready to tackle the two database models I have here. The Microcosmos database and the Macrocosmos database. The Microcosmos database covers solid matter properties, including interatomic distance, valence, specific heat, energy and entropy, thermal expansion, compressibility, electrical and magnetic properties, isotopes, and atomic spectra. Also covers liquid, vapor, and gas matter properties, including volume and density, specific heat, energy and entropy, viscosity and surface tension, and electrical and magnetic conductivity. And today we covered cosmic elements. Next week we'll be covering material and cosmic subatomic particles. And then we'll have photon properties, and then we'll take a look at the graphing module here. I've already covered the Macrocosmos database, so please see my previous screencasts. I've covered these astronomical properties for the universe as a whole: galaxy clusters and groups, galaxies, star clusters, stars, planets, moons, minor bodies, nebulae, gas, and dust, and voids. And you can just click on the events if you just want to go look at the pictures and videos. This also has a nice graphing diagram for the progression of gravitation and star properties. Now, my theoretical physics mentor, Joby Larson, was also a theoretical economist, and I've made his work in economics also fully computational. That work is called Optimal Economist, an Implementation of Larsonian Econophysics. And there I cover the economics of individuals and businesses and business sectors. That's microeconomics, and I also cover macroeconomics, the economics of whole regions and countries. Totally supersedes the conventional nonsense of Keynesian economics. And I really wish that more people would be purchasing that particular program. It would help having more people understand how economics actually operates. Okay, well that does it for today. I've covered cosmic elements in some detail. Again, please study the reciprocal system and prove it for yourself, and thanks for your attention.